Everybody, this is Tim. We're going to talk about disk encryption at Fleet. So disk encryption should be a familiar concept to everyone here. It's a critical component of device security. It does come with two complications. As an admin, I need access to a device data when the employee leaves the company. And also, as an end user, I need access to device data if I lose the password that encrypts that data. And so what do? We store, or as we say, escrow keys to a safe place. And Fleet does that currently. It's a pretty robust MDM that already supports encryption key escrow on Windows and Mac OS. And we are now rounding out our cross-platform MDM support to include key escrow on Linux. So what is LUKS? What is this LUKS word? LUKS stands for Linux Unified Key Setup. If you have any detailed questions about the protocol, Lucas ran a very thorough POC that set us up for success here. He's a very smart guy. So it's important to note Fleet cannot enforce encryption on a Linux device like we can on Windows and Mac OS. So to address that limitation, when disk encryption is enabled on the team, those devices in that team will see a notification in Fleet Desktop pointing them to a guide on just how to do that. Now, for devices that are already encrypted, we can start the key escrow process. So end users will trigger it through Fleet Desktop, which sends a request to FleetD. FleetD then prompts the end user for the current encryption passphrase. It uses that passphrase to create a new passphrase, which can then be escrowed to Fleet. Now I'm going to repeat this because it's important, and that is that FleetD creates a new passphrase. It does not replace the existing passphrase. The existing passphrase is not escrowed. Both passphrases can decrypt the LUKS partition. So this passphrase is securely transported over TLS like all FleetD traffic is today. It's encrypted with the server private key, which is a requirement for this feature, before storing in MySQL. Now when a Fleet admin needs to retrieve this key, it's retrieved from MySQL and decrypted via the server private key before being displayed in the host details page. As with viewing all disk encryption keys, this activity is recorded in the activity log. Now it's time to demo. All right, as you see here, we have a Linux device. We're going to open Fleet Desktop. As you can see, it's showing OS settings here in a pending state, as well as a banner. We're going to click on Create Key. This is where it's sending the request back down to FleetD. We get prompted for a passphrase. Enter a passphrase. We're going to fast forward a bit here. We get a success dialog. Now if we close these windows down, refresh our page here, see the device is now in a verified state.